All right, so in 19.3, we're going to look at additional properties of exponents. Our goals today: develop the power of a power of a product, and the power of a quotient properties, and simplify expressions using exponents. So as part of your homework, you were to look ahead through this section and fill in the definition for the power of a power, power of a product, and power of a quotient property. So I said that you didn't have to understand them, but I wanted you to read through them and kind of be familiar with what they say, and then we'll discuss to develop that understanding. So number one here, we are going to fill in this table. So we have 2 squared 4 times. So 2 squared to the 4th. So this is saying that we have 2 squared how many times? 4 times, right? So we have 2 squared, 2 squared, 2 squared, 2 squared. But then we can expand 2 squared. What does 2 squared mean? How many times do we have 2? We have 2 times, right? So this is 2 squared 2 times, 2 squared 2 times, 2 squared 2 times, 2 squared 2 times. So how many 2's do we have? We have a total of 8 2's. So 2 squared to the 4th power is the same as 2 to the 8th. So now let's look at 5 to the 5th to the 3rd power. So this is saying that we have 5 to the 5th how many times? 3 times, right? Can we expand that further? Yes. So this 5 to the 5th times 5 to the 5th times 5 to the 5th. How can we expand 5 to the 5th? That's saying we have 5 how many times? 5 times, right? So we have 1, 2, 3, 4, 5. So that's this 5 to the 5th. And then we can write this 5 to the 5th as 5 times 5 times 5 times 5 times 5. And we can write this 5 times the 5th times 5 times 5. So how many total 5's do we have? 5 to the 15. Because we have a total of 15 5's. Alright, so x to the 3rd to the 4th. This is saying that we have x to the 3rd how many times? 4 times. Can we expand? This x to the 3rd is like saying we have x how many times? 3, right? So how many total x's do we have going on here? If we expand this to x times x times x? What pattern are you noticing? So when we have a power to a power, what are we doing with our exponents? We're multiplying them. So down here, if we have a to the n power, this we can rewrite this how? Mn. So a to the n power. All right, number 3 says use the power of a power property to write x to the 6th fifth to the 25th as a single power. So this is saying that we have 5 to the 6th fifth power how many times? 25 times, right? So what are we going to do with our 2 exponents? Multiply them. So what's 6 to the 6th fifth times 25? What is it? 30. So we can write this as x to the 30 power. So the power of a power rule is telling us that what are we doing with our exponents? Multiplying them. So on your table, make sure that your power of a power, kind of in your own words, define it. And then make sure that under the rule, you have this a to the m to the n, simplified as a mn. And then give yourself an example. You have a bunch there to choose from, or make up your own. Questions? All right, so now we're going to look at the next property. So write each expression and expand expanded form in group-like terms, then write the expression as a product of powers. So here we have 2 to the x 4 times. So we have 2 to the x how many times? 4. So we have 2 to the x times 2 to the x times 2 to the x times 2 to the x. And this next step, what's going on? All right, so they've grouped all of the coefficients together and all of the x's together, so grouped being like terms. So we have 2 how many times? 2 to the 4th power times x to the 4th power. Now can we simplify 2 to the 4th if we were going to go one step further? What would be 2 to the 4th? What's 2 times 2? Times 2 times 2. So this can also be written 16 times x to the 4th. All right, so let's look at negative 4a to the 3rd power. So our base is at negative 4a because that's what's happening 3 times. So negative a, we're going to write it how many times? All right, can I group my like terms? All right, so how many times I have that? Negative 4 times negative 4 times negative 4. So how many times is negative 4 happening? 3. Make sure you put parentheses around that. And that'll have to do with your calculator because your calculator is really not as smart as you think it is. And then we have a times a times a. So we have a to the 3rd power there. So we have negative 4 to the 3rd power, and then a to the 3rd power. All right, let's do this last one. So here, what do we have going on? We have 2 things. We have 2 letters on the inside, 2 variables going on in the inside, and everything's being raised to the 4th power, right? So we have x to the 3rd times y squared, and that whole thing, that whole quantity to the 4th power. So how are we going to write that? Paul said we have x to the 3rd, y to the 2nd, 4 times. Does everybody agree, or do you have something different? What do you think?
I agree.
Okay, how are we going to agree?
My friend told you.
I agree too. So we have y cubed, x cubed, y squared. We're going to have that happen 3 times. 4 times. Alright, so we have 1, 2, 3, 4. So it's happening 4 times. Alright, but now what? Alright, we can group. So I have x cubed. And I have my y squares. Alright, so now how can I write that? I have how many x cubes? And how many y squares? Can I simplify that a little bit more? What can I do with the exponents? Alright, so this is going to become x to the what? And then y to the Alright, how are we feeling about that? So based on the pattern you observed in item 4, write the missing exponents in the box below to complete the power of a product property. So we have AB to the M. So this would be the same as A to the. If this whole thing is being raised to the M power, then what's each of these individual terms going to be raised to? M. So A to the M, B to the M. Alright, so use the product of a power of a product property to write C to the 1/2, D to the 1/4, the whole thing to the 8th power as a product of powers. So what are we going to do with our 8? Our 8 here, is it just going to sprinkle its exponent font on one term? No, it sprinkles it on everything inside the parentheses, right? So we have exponent sprinkle power going on. So we have exponent sprinkle power. So we have C to the 1/2 gets sprinkle power. And D to the 1/4 gets sprinkle to power. So how do we simplify that? So there's C to the 1/2. Sprinkle power, right? D to the 1/8 gets exponent sprinkle power. C4. All right. Questions? Make sure that you add, if you did not have that, make sure you add that, or if you wrote the book definition, make sure you clarify. So what is the power of a product property? Make sure you have this general statement and then give yourself an example. Before we move on, I want to look at one thing.